So welcome to this practice seminar or practice webinar for your quiz number 1. And so the first thing we're going to do is go through some Kahoot questions, and they're the sort of thing that to help you think about what you need to know for the quiz, so that they're related to the sort of questions that you will get on the quiz. So if there's a topic that you don't understand in the quizzes, in the Kahoots quiz, you'll know that you need to learn more about the topic for the quiz itself. At the end, we will look at a couple of people have emailed questions that they'd like me to cover in the tutorial session. So we'll look at them. And then, of course, if you guys have any other questions, we can talk about them as well. So if you can log on to Kahoot. Emma, that's fine. Okay, so the first question is about the periodic table. So do the number of shells in the atoms increase as you go across the groups in the periodic table? Oh, I must have done that too fast. So only 5 of you got to answer that. Okay, so 4 of you said that was true and 1 of you said that was false. So as you go down the periodic table, the number of shells increases. But as you go across the periodic table, it's going to be something else that increases. So do you all remember what the names of the columns and the rows in the periodic table are called?
Periods and groups.
Yep, so which one are the groups?
The groups go like up and down, or yeah, sorry, my words aren't working tonight.
Yeah, so like a column.
Across, yeah.
So yes, so the shells, the number of shells is going to increase down the groups in the periodic table. And then if we go to the next question. So the next one is about the number of electrons in that outer shell. Do they increase by 1 electron in each period? So the question is saying, as you go down the periods, which are the rows, do we get more electrons, like 1 more electron down each row? And so 4 of you said yes, and 4 of you said that was false, and 3 of you said yes. So yeah, as you go down, that's where the number of shells increases, and as you go across the groups, you will get the increase in the electrons. So as you go across, you've got group 1, group 2, group 3, 4, 5, and so you'll get 1 more electron in each of these groups, and then the shells, as you go down, you're increasing the number of shells in the periodic table. And of course, the periodic table, something else you should know about it is that we have the metals and the non-metals, and they're separated through here where the blue and the purple intersect. And there's actually something interesting that I should point out to you, because whenever I see this periodic table, I don't actually like using this one, but it's the nicest. It's got everything on it, so it's really good to use, but it's also wrong to use. And that is, can you see how it has the UUT, UUP, UUS, and UUO here? That means at the time that this table was made, these elements weren't known, but these elements are actually known now. And if you look here, you can see that they've actually got names. If you see a periodic table that doesn't have all of these elements listed, then you know that it's an old one. So why is the atomic number of an atom important? Okay, so 6 said that the atomic number tells us how many protons are present in the atom, which is the correct one. 2 said the atomic number tells us how many electrons. The number of electrons changes because you know how when we do ionic bonding, can lose an electron from the outer shell and it'll go from one atom to another, and so you'll get a positive charge on one atom and a negative on the other. So obviously the number of electrons are changing. So if that is how the atomic number was calculated, then that would mean that the atom would be forever becoming a different item. So it wouldn't always be that one atom if we use the electrons. So the atomic mass gives us information on the mass of an atom. Which of the statements is correct? So 7 of you said that this mass is calculated by adding up the number of protons and neutrons. And 1 of you said that this mass is calculated by adding up the number of electrons and protons. So the electrons don't weigh very much at all, and so their mass is negligible. So always think about just the center of the atom and add up the things that are present in the center. So how many protons, neutrons, and electrons are present in carbon, as in C12, which is an isotope form of carbon? And so, of course, C12, 6. So the 12 is, sorry, the 6 first is the atomic number, and the 12 is the atomic mass. So 5 said that there's 6 of each one. 3 said there was 6 protons, 12 neutrons, and 12 electrons. But don't forget that the 12 stands for the amount of neutrons and the protons added together. So you would half that number to get the number of protons and the number of neutrons. And of course, the electrons is roughly approximately the same number as the protons, unless it's in an ionic form. And so, of course, that should be 6 as well. If you have any questions about any of these, make sure you either turn on your microphone or just type in the chat box, and then I can answer them as we go. So here's the structure of an atom. What do A and B represent? Okay, so 3 of you said that A is the nucleus of the atom, which it is, and then you said, but that's where the neutrons are present. So yes, the neutrons are present in there, but there's something else also in there. And the other thing that's present in the center is the protons. So here's a couple of things that you can fill in the gaps. Protons carry some sort of charge, electrons carry a different charge, and neutrons carry some sort of charge. So which of the options is correct? That was fast. And so you got it right. Oh, 1 person said positive, neutral, and neutral. So the electrons have a negative charge. The protons are positive and the electrons are negative. So when there's the same number of protons and the same number of electrons, then the atom is going to have a 0 overall charge. So what's the difference between an electron shell and an orbital? Okay, so we had a pretty big tie going on there. So 3 said shells have electrons containing similar energies. That's correct. And 3 said orbitals have 2 electrons from one shell. And that's also correct. So the actual answer is all of the above, because both of those statements are correct. So everyone was correct. It's just that some of you didn't get all of the statements that were correct. So which statements are true about how the electrons occupy the orbitals and the shells? So 7 of you said that all of the above answers were correct, and 1 person said that only the electrons fill the shells closest to the nucleus first. So that statement, of course, is correct, but the others are also correct. What is a mole? Okay, so 7 of you said a mole contains 6.022 by 10 to the 23 atoms, and someone said green. Red and blue answers are correct. So they also said that 1 mole of a compound is 1 gram of the compound, and that's not quite correct. 1 mole of a compound equals the amount of grams of the molecular mass of the compound. So if the molecular mass of the compound is 12, then it would be 12 grams of the compound. So in this balanced equation, if we have 1 mole of calcium sulfate, how many moles of sodium nitrate are required to react? No, that's sodium nitrite, actually. Okay, so 1 person said we can't consider moles in this equation, but we can, if I just find it here. Okay, so if we look at the question, so if we have 1 mole of calcium sulfate, this equation says that if we have 1 mole of calcium sulfate, then we need 2 moles of sodium nitrite to form the products. And that way, and we end up with 1 mole of calcium nitrite, calcium dianitrite. I'm not quite sure how that name's meant to be said, but it's 2 lots of nitrite plus sodium sulfate. So only 1 mole of this and 1 mole of this, but to start with you need 1 mole of the calcium sulfate and 2 of the sodium nitrite. So if you change this and you started with 2 moles of calcium sulfate, it's going to react with 4 moles of the sodium nitrite, because you'd have to double that number too. But you'd only be producing 2 of this product and 2 of the sodium sulfate. Disodium sulfate. So did anyone have any questions on how that worked? Oh, it was only 1 person that didn't understand it. Are you right with that now? Or you can always ask a question later if you wanted to. Actually, can you see, when I swap to the PowerPoint, can you even see it? You can't, can you? Thanks for telling me. I'll just show the PowerPoint. Yes. Okay. So you can see that in the question, calcium sulfate has no number at the front of it, so it doesn't have any coefficients. So it's just the equivalent of saying we have 1 mole of calcium sulfate. Then because this product here, the sodium nitrite, has a 2, that's the equivalent of saying it has 2 moles worth. And the products neither of them have coefficients out the front, so it's also like saying 1 mole of each of them. Okay, back to Kahoot. Next question. What is ionic bonding? So is it the equal sharing of electrons, the loss of an electron from one atom creating a positive charge, the gain of an electron by one atom creating a negative charge, or is it the simultaneous occurrence of the yellow and blue answers forming the charged molecule? And 8 answers already, so I'll skip ahead with that. Oh, everyone's done it. And so one person said yellow, so they said it's only the creation of a positive charge, but it's also, you also need to have an atom at the same time that's gaining the electron and creating a negative charge, because it has to happen simultaneously on 2 atoms. Once charged, what happens in ionic bonding? The positive charged atom and the negative charged atom attract each other. The charged atoms bounce freely around in the solution, or the charged atoms regain their electrons. Okay, so 8 of you said that the positive charged atom and the negative charged atom attract each other. So you could see that in the picture. And one person said that the charged atoms bounce freely around in the solution. So no, they do tend to bind to an opposite charge. So what occurs when covalent bonding happens? The electrons from the atom with the least electrons move to the other atom. The unpaired electrons are shared evenly between the 2 atoms. The octet rule is satisfied, or are yellow and blue both correct? Okay, so everyone said that yellow and blue are both correct. What sort of bonding is represented in the following diagram? Is it a polar ionic bond, an ionic bond, a covalent bond, or a polar covalent bond? Okay, so 7 said it's a polar covalent bond and 2 said it's a covalent bond. So you're half correct by saying covalent bond. It's just that it is unevenly shared because there is an electronegative charge that affects the ability of the hydrogen and the oxygen to share the electrons, so they are shared unevenly. I'm just going to go to the PowerPoint again. Okay, so this periodic table is special. It actually shows the electronegativity of the atoms. And so you can see, if you look on the scale, the most electronegative atoms are shown up in red, and the decreasing colour down to the purple shows ones that are the least electronegative. And so if two atoms are bound together in a covalent bond, but they have completely different electronegative charges, then one will tend to pull at the electrons more than the other. So oxygen is shown here and it's red, so it's highly electronegative, whereas hydrogen is yellow, so it's not as electronegative. So oxygen will pull at the electrons more than hydrogen does, and that's where the polar covalent bonding comes in. How does maybe I explained it too soon. How does polar covalent bonding work? So is it equal sharing of electrons? Does oxygen have a slightly larger pull on the electrons, or does hydrogen have the slightly larger pull? Okay, so 7 of you said that oxygen has a slightly larger pull on the electrons, and we did see that oxygen is more electronegative, so that's why it has the stronger pull on the hydrogen. On the electrons, whereas hydrogen is less electronegative, so it doesn't pull on the electrons as much. In redox reactions, what does this mnemonic represent? So is it oxygenation is the loss of oxygen and the reduction is the gain of oxygen? Oxygenation is the loss of oxygen and reduction is the gain of hydrogen. Oxygenation is the loss of hydrogen. Yep. So 3 of you said oxygenation is the loss of hydrogen or electrons, and the reduction is the gain of hydrogen or electrons, which is the full answer. 2 of you said the first one. So oxygenation is the loss of oxygen. So oxygenation is actually the gain of oxygen. So it's the loss of hydrogen or electrons, but it's the opposite of oxygen. So it's the gain in oxygen, and reduction again is going to be the opposite to what you're with oxygen. If you're gaining the hydrogen or electrons, you're going to be losing the oxygen and vice versa. So in the following redox reaction, which atom is reduced and which is oxidized? Okay, so 6 of you said that copper is reduced and silver is oxidized. So we'll just look at that on the PowerPoint. Okay, so here's the reaction. So copper at the moment on the left-hand side is in the solid form, and copper is going to 2 plus. So if it's going to 2 plus, is it gaining electrons or losing electrons to become 2 plus?
Losing.
Yep. Does everyone agree that it's had to lose electrons to become 2 plus? So if copper has lost electrons to become Cu2 plus, is that oxygenation or reduction? So oxidation is the loss of electrons or loss of hydrogen. So if copper has become copper 2 plus and it's lost electrons, is that reduction or oxidation? So Maddie, reduction is the gain of electrons or hydrogen. So copper has gone from having no charge to 2 plus, so it's lost 2 protons. So oxidation is the loss of hydrogen and electrons. So if we look back at the question, so you can see copper is, so a lot of you said that copper is reduced and silver is oxidized. So copper in this case has lost 2 protons, sorry, 2 electrons. So it's Cu2 plus now. So if it's lost electrons, then it has been oxidized, not reduced. And so the answer is going to be copper is oxidized, and of course the opposite is going to happen for the other atoms, so silver is reduced. So don't forget, when you guys do the exam, you actually will have the camera on you, so it might actually pay to start practicing and just having it on, because you're going to have it on eventually anyway. Of course, some of you might not have a camera yet, but that's fine. A is an example of an equilibrium reaction. B goes forwards only. Are those statements true or false? Okay, so everyone said that's false. And so it's actually the opposite way around. Oh, Vic's going really well. In an equilibrium reaction, what occurs? So here's our equilibrium reaction. So which of these statements is correct? Okay, so 7 said that blue and yellow answers are correct. 1 said red and 1 said blue. So the red answer was all the reactants will be used up forming the product. And the blue one was the equilibrium point consists of some reactants and some products. So we might just look at the PowerPoint. So one of you said this one, all the reactants will be used up forming the product. So basically, if all of the reactants were used up forming the product, that would be a reaction that's only going in one direction. When there's an equilibrium occurring, not all of the reactants form products. So you'll get some reactants in the mix and some products, but not all of one and none of the other. And what was the answer that some people got? Someone said blue. Okay, so the equilibrium point consists of some reactants and some products. So yes, that's correct as well. But the yellow answer is also correct because the equilibrium point in the reaction is going to be affected by temperature, pressure, and concentration. And we'll talk about that later in case anyone has some more questions on that. So what is the Bronsted-Lowry definition of an acid? Is it that an acid is a proton donor, an acid is a proton acceptor, or that an acid burns the skin? Okay, so 7 said an acid is a proton donor. And so, of course, an acid loses its extra hydrogen and donates it to the base, and the base accepts the extra hydrogen. So hydrochloric acid is a strong acid. What does that mean? Does it mean that in an aqueous solution, all of that hydrochloric acid dissociates, and so you don't have any HCl left? Does hydrochloric acid easily donate all of its H+, or are both of those answers correct? Okay, so 2 of you said that hydrochloric acid easily donates all of its H+. So that's correct, of course, but also the first statement is also correct because the HCl fully dissociates. So you don't tend to have HCl left in the solution, only the H pluses and the Cl minuses. So hydrofluoric acid is a weak acid. And what does that mean? Does it mean that hydrofluoric acid is stable and donates few protons? Does it mean that about 85% of the hydrofluoric acid dissociates? So there's not much hydrofluoric acid left? Does it mean that the fluoride ion is more stable than the hydrofluoric acid? Or most of the protons in hydrofluoric acid react with water, leaving little behind? So we've got a mix. So hydrofluoric acid is stable and it donates very few protons. So one person said that fluoride ion is more stable, but no, it's not, because the hydrofluoric acid tends to not want to give itself away, so it wants to stick together. And one person said most of the protons in hydrofluoric acid react with water. so very little HF remains. But that would be the case if it was a strong acid. So a strong acid is going to really want to donate its hydrogen, so it's going to dissociate, whereas a weak acid doesn't want to donate its hydrogen as much, and so it wants to hold it to itself. So you'll find that on average, a weak acid will only give away about 15% of its hydrogen. And what's the function of a buffer? Does it help the pH of a solution change rapidly? Does it help the reactants remain in equilibrium? So 7 of you said that a buffer helps maintain the pH of a solution. Yes, that's the answer. 1 person said a buffer helps all reactants remain in equilibrium. So I guess that could be the case as long as the equilibrium is going to keep the pH correct. Bicarbonate from a buffer can react with the hydroxyl ion. Which statement related to this is false? So here it's saying, is this hydroxyl ion a base? Does the weak acid here neutralize the hydroxyl ion to form these products? The conjugate base in the reaction is water, or the conjugate acid in the reaction is water. Okay, so 5 of you got the right answer. So the conjugate acid in the reaction is the water. So maybe we'll just look at the PowerPoint of that question. Okay, so you can see that we have the bicarbonate, and this is acting as an acid. And you can tell it's acting as a weak acid because there's an equilibrium symbol here. And of course, if you have something that's the hydroxyl ion, you know that it's a base. So you've got your weak acid and the base. And so the weak acid and the base are reacting together. So the bicarbonate ion is donating its hydrogen and it's donating it to the water. So that means that the bicarbonate ion is the weak acid, and its conjugate base in this reaction is going to be the carbonate. That means that if that's becoming the base, then the water is acting as an acid, and its conjugate base is this one.
I've been robbed.
I better write a note about that one and make sure I change that completely. It's what happens when you guys are the guinea pigs for a quiz. But the important thing is that you learn. It's not about winning. Okay, the bicarbonate ion can also react as a conjugate base. So which of the following statements is false? Have we got it right here? Okay, so we've got some dissension. Let's look at it. So we have the bicarbonate ion here, and it's reacting with the hydronium ion, and carbonic acid here, and you can see it's got the 2 H's. So if we look backwards, you can see that the carbonic acid has donated a hydrogen to the hydronium ion, and that's why this is the conjugate base. So this is the acid, and this is its base. And so then if we look at the other pair, that means that this has to be the acid and this is its base. So look for the one that's giving away its hydrogens, and you know that that's the acid, and the version with one less hydrogen is going to be the conjugate base. So, yep, Kat, the best way is to look, you can look for the base first if you like, but I always look for the acids, but you can do it the other way. Just look for something first and then you can find the other pair. Okay, back to, I think we're almost through the Kahoot questions now. In fact, we're finished. So Sophie, you came third. You were winning at first, but the big winner was Jaden. Congratulations.
Yeah, I was robbed.
Good attempt, everyone. And so, of course, it's not about the winners. You guys did well, but it's about the learning. And now, unless everyone has some questions they want on what we've just done before I go over some tutorial questions that I've received, we'll go into the tutorial questions. Maddie, are the questions that were in the Kahoot quiz the only topics that will be in the quiz this week? So that covers pretty much all of the sort of topics that you'll be looking at in the quiz. So you'll see some questions on buffers, ionic bonding, covalent bonding, probably a polar bonding question, oxidation and reduction questions, and about the shells and electrons, molecular mass. So it's basically all of the sort of things that should be covered in the quiz. No, Morgan, you are not filmed in the quiz, only the exam at the end.
Are there going to be just multiple choice questions, or is it going to be like paragraph answers as well?
Just multiple choice questions. Paragraph answers is too hard.
Yeah,
And you've
agreed.
only got 30 odd minutes to do it in.
Yeah.
Emma, is the exam online? Yes, the exam is online. Kat, the quiz is an open book. You can have whatever you like in front of you. Oh, actually, I'll just go through this before we start on the tutorial questions. So when you're preparing for the quiz, make sure that you do the practice quiz, which is in the week 3 tab, and it's always handy to do that a few times, and that will help you get used to doing the quiz questions, and hopefully it'll also highlight any other questions that you don't fully understand yet, any topics that you don't understand. If you need any help in the preparation, you can post questions on the loop. You can post them on Facebook. I don't know, have you guys got a Facebook Messenger group going? So you can always ask each other questions, and then if you guys can't answer it amongst yourselves, then you can ask me by posting on the loop or in Facebook. Do the weekly review quizzes, because they're a good way of helping yourself remember things as well. If you are not understanding a topic, see if I've posted a video on that topic on Padlet to help yourself. And of course, I've created the summary sheets to help you with each topic, so you can have a look through and see what, remind yourself of what was covered in each session with the summary sheets. Maddie, what's the Facebook chat? Okay, so through Facebook, you have the Facebook Messenger program. I'm not sure exactly what you need to know about that question, so just go back to the basics. So I created a Facebook page, and so everyone on that, I presume someone has set up a Facebook Messenger chat group amongst yourselves, and I've chosen not to be involved in that, as I've found that the last group I had was talking too much about their results and things, so I felt like it wasn't really a place for me to be, and that you guys should have it just amongst yourselves. But there is the Facebook group that if you want to join it, then hopefully whoever's doing the messenger will see that you've joined Facebook, the Facebook group that I have posted about on the loop, and then you can join the Facebook chat as well. Okay, so now if we go to the tutorial questions, so someone had a question, someone wanted question 1 from the session 4 tutorial. Oh, that's right. First of all, they wanted an explanation of these graphs. So we'll just go through. Oh, okay, so it was Parlak that created the messenger group. So Maddie, if you join my Facebook group that I created for BIOB111, then Parlak can easily add you to her chat group. Oh, Kat, no, you can't go back through the Kahoot quiz on your own again because it's a timed thing and I have to actually sit here and run it. But you can watch the video when it's available and think about the questions in the timing again. So the first question that someone wanted me to go through was from session 4, and first of all they wanted an explanation for these graphs, and so these graphs are on the equilibrium. So you can see here in this first graph you've got the reaction rate on the y-axis and the time on the x-axis. So what this is showing is what happens as time progresses, and it's showing on here how fast the reaction goes as it goes up the y-axis. So you can see it's got a red line, which is the rate of the reverse reaction, and the blue line is the rate of the forward reaction. So just, it's got this annotate thing. Let's see if it'll work for me. I think it will. Okay, so if we have x plus y, and it's forming the product xy. So the forward reaction in the equilibrium is from the reactant side to the product side. And the reverse reaction is going in the opposite direction from the product side to the reactants. So in an equilibrium, when you start off, you'll have the solution and you'll stick in x and you'll stick in y. And so when they're first in there, they've only just met each other. So there's lots of x's and lots of y's that are going to be separate. And so as time goes on, they're going to be interacting with each other, and you'll find that you'll end up with a solution that has a lot of x and y bound together and not as much separate. So there'll be some separate still sitting in the solution. And so what this is showing here on the graph is this blue line is the forward reaction. So that's where you've put x and y in the solution, and at first nothing has reacted together, but as time has gone on, they've started to bind. And so it's showing here that the reaction rate starts really, really fast because there's so much x and y that hasn't been bound together. So your reactants are there, they haven't bound to anything, so they will easily come across each other and start binding. But as more and more of them bind, that it starts getting harder for the others to find something to bind to, so the reaction rate is going to slow down. And of course, as it slows down, it forms the equilibrium. Whereas the reverse reaction, which is when you have the bound product and it's going to form the unbound product. At first, because there's not much bound product, that reaction is going to happen really, really slowly. But as more and more of the reactants bind together, then there's going to be more bound products. So it's going to be able to do the reverse reaction and form more of the reactants. And so that speed of reaction is going to speed up. And so at some point it will reach this equilibrium where the rate of the forward reaction, which is going the unbound X and Y into the bound form, is going to be as much as the reverse reaction. And that's the equilibrium point. Does that make sense? Okay, and so in this second diagram, you've actually got, it says concentration of moles per litre. And so that's the concentration of what is being created, or of the products or the reactants. And it's again showing time along the x-axis. And so you can see here, we've got the products. And so as the concentration, the concentration of the products is going to increase with time from the start, and the concentration of the reactants is going to decrease. So this one is a bit different. It shows equilibrium, and it's got an arrow here. So what that's really showing is that the equilibrium could be anywhere between these two aspects depending on the actual situation that it's in.
So does equilibrium then exist, like you get a different concentration of products from reactants basically? Like
Yep.
it can happen at any point?
Yep.
Yep.
Yes. And so it's going to depend on the concentration, like the concentration of the reactants or the products in there. It depends on the pressure and the temperature. So it could be that you've got a lot more of X and Y, or it could be that you've got a lot less of X and Y than you have of X and Y as in the products than of the reactants, or it could be vice versa. Okay, so the first question from that tutorial was, what is a reversible reaction? So from that, does anyone have any problems understanding what a reversible reaction is? So you're all fine, understand a reversible reaction. So there was a question associated with this because the answers, yep, I did put them here. So you can see that the answers for each of these questions is actually quite long. You don't need to worry about the length of answers because in the quiz it's all multiple choice. So you just need to make sure that you understand them. So question 2 was, use the information from the diagram below to describe what happens at a chemical equilibrium. So we've discussed that. And then use the information from the following diagram to describe what happens at a chemical equilibrium with respect to the concentrations of the reactants and products. So I guess if we look at the reactants and products one, just find the annotate thing again. Might just change the color since that scribble is going to stick there. So if we do A and B, okay, so if we injected more A into the system, what's going to happen to the reaction?
It's not going to be in equilibrium.
Not at first when you add it in, but it will reach a new equilibrium. And so can you think about how it's going to affect the equilibrium? So basically what would happen is, because all of a sudden the system's overloaded with A, more of the A will want to react. So it will react with some of the B. And so you'll get a decrease in B, but you'll get an increase in AB. And of course, there'll be more A than there was originally because you've added more. And so not all of it will be able to react with the B. And so it acts a bit like a seesaw. And so as you put more of the A in, it's going to make it sort of top heavy, bottom heavy. And so it's going to want to even itself out. And so that's sort of how the equilibrium works. If you think about it, it's a bit like a seesaw. Put more on, and then it's got to figure out how to balance itself somehow, because it'd rather be even. But that even point changes depending on the conditions. Le Chatelier's principle. Yes, Glenn.
This isn't to do with that, but with
Mm-hmm.
the final quiz, is there going to be any paragraph answers, or is it again all multiple choice?
You mean the final exam?
Yeah, the final exam.
There will be. And
Yeah,
so much closer to that, we'll go through those sort of questions, because none of this will be on the exam.
yeah.
So you just have to do this quiz, and then you won't have to be tested on this anymore. So then we have this question. So identify each reaction as either endothermic or exothermic. And so to determine if something's endothermic or exothermic, you need to have a little bit of information. So you can see it could be that it says the plus 93.9 kilocalories, so it actually can give you an idea of the amount of energy. Or it could just be that it uses this term heat. And another way of doing it, of course, is over here. We're actually told the change in the heat. And so you can see that the first one, the delta H, is minus 93.9 kilocalories, because the kilocalories are on the product side. So if it's minus, it's going to mean that the energy is on the product side. And that means if the energy is on the product side, is it being produced or used?
Produced.
Yep. And so you can see this third one, it's plus 21.6 kilocalories. And so it means that that energy is being used in the reaction. And you can see the last one is plus heat again. So the delta H is negative. And so from that, you can determine if something's endothermic or exothermic, because you can see in 3 of these reactions, that one, and that one, heat is produced by the reaction, whereas only one of them is using the heat. So from that, you should be able to determine whether it's endothermic or exothermic. Okay, so this is an equilibrium reaction one. So we have nitrogen, hydrogen, and ammonia. So what happens when ammonia is added to the chemical system? So we've got this in equilibrium, and then more ammonia is being added. So it's more product. So don't forget, if it goes this way, if the reactants are forming products, that's called a forward reaction. And if the products are forming reactants, that's a reverse reaction. So which situation matches the addition of ammonia in this equilibrium? So the rate of the forward reaction increases. So this is a forward reaction in that direction. As additional product is made, the rate of the backward reaction increases. That's this way. As additional product is made, the rate of the backward reaction increases as additional reactants are made, or the rate of the forward reaction increases as additional reactants are made. So Victoria says the backwards as additional reactants are made. So she says that we're going to go this way and more reactants are being made. So does everyone agree with that one? So yeah, so that's the answer to that one, because of course you've got lots of ammonia in the system, and now it needs to balance out. So some of the ammonia has to be converted into the original reactants to balance the reaction. Does the equilibrium below favour the reactants or the products? So in this one, we have hydrofluoric acid, which, can you remember if that's a weak acid or a strong acid?
Weak.
Yep. So it's a weak acid, which means that it's going to exist in equilibrium because it's going to be much more stable in the hydrofluoric acid form because it doesn't want to give away its hydrogens. So the question is, or so are the reactants favoured? The reactants being the hydrofluoric acid and the water, as it's a weak acid, or are the products favoured because it's a strong acid?
Would it be A?
Yep. Yep, because it's a weak acid, so the reactants are favoured. So the reaction isn't going to go in the forward direction as much as it's going to go in the reverse direction. And oh,
sorry, just butt in. When it says favour the reactants or the products, why is it saying, what does favoured mean?
favoured means, is the equilibrium point going to create more of those things? So is there going to be more reactants present than products?
Okay.
Okay, so Kat just wants me to run through it again. So if it's favoured, I'll get my annotation again. So in the reaction, when it's favoured, it means that more of that side is going to be produced. So when we have a weak acid, like hydrofluoric acid, it doesn't want to dissociate. So it's going to be, like, if you think about it, its forward reaction could be just a little arrow, whereas its backward reaction will be a big arrow, because the hydrofluoric acid doesn't want to give away its hydrogen. So it doesn't want to form these products. So these products might only occur about 15% of the time. That means that 85% of the compounds in solution will be the hydrofluoric acid and the water. So that means that this side is favoured because there's going to be a lot more of the reactants present. So that means that that's the reverse reaction that is favoured, because the hydronium ion and the fluoride ion are going to want to react together to form the HF, which is a much more stable product. So you're all happy for now? And you can always post, like, there's quite a few days before your quiz is due. So, of course, make sure you do it before Sunday evening, because sometimes things go wrong when people try doing it after about 7, 8 o'clock on a Sunday evening. So make sure you get it done earlier, otherwise you may find yourself studying the subject for a few more days before you can actually get the quiz out of the way. If you've got any other questions, just post them on the loop, or of course chat amongst yourselves on Facebook Messenger if you want to. And that's all. So thank you all for coming along and participating.
Thank you.
You're welcome, and see you next time.